Alright, hello and welcome to Spreadsheet Skills. So today I'm going to be going over a bunch of little tips and tricks that will help you get the most out of Excel, because one day you're going to have to make some graphs or tabulate some data in a pretty way, and I want to show you some things that will help you save time and just make everything look nice. Okay, so let's get started. So here's my running example for this little mini lecture. Let's pretend we're sitting in a physics class or a physics lab, and today we're dropping a ball off a very tall building. Okay, that's the game. We're studying kinematics right now, and the building is 20 meters tall, and we also have placed a sensor at the bottom of the building to tell us at regular intervals how far down the ball is. So at the very top, it notices that it's at 20 meters away from it exactly, and then when we drop the ball a little bit after a certain amount of time, maybe it's at 18 meters, and it can track all of that for us. Okay, so that's what the sensor's doing, and so we've got a bunch of data from this sensor about where the ball is over time on its path down to the bottom. Okay, and so we'd like to put all of that into a table and graph it nicely and just make everything look cool. Okay, so let us get started with the spreadsheet. So here I've filled in some of our data from us dropping the ball. I've got time and position. We can make that all pretty in Excel by making it bold, making the font larger, things like that. Whatever you want to do, that works pretty normal to like Word or PowerPoint or things like that. You can zoom in and out down here, but let's assume we've got this data and we'd like to complete it. So here are the time and position pairs for the sensor. And right now, I'm missing a few of the times, right? This should have been 1.8 was at this position. This should have been 1.7 was at this position. But I'm lazy and I don't want to type that 1.8, 1.7, 1.6 a million times. Excel can do that for us. We can automatically fill in the rest of those times just by letting Excel follow the pattern. So if I highlight these cells, we call them, and I start dragging down from the bottom right, Excel notices the pattern and will fill it in for me. Isn't that cool? So I can go way down here, all the way to 0, times 0, and now I've got all my time and position pairs. So I didn't have to fill in everything myself, just the actual readings that are different each time. Okay? So that's my data, and I'd like to graph it where time starts at 0, right? Because that's where the ball's initially at the very top of the building. So it looks like I filled in my data backwards. Let's do something about that, okay? So let's use a filter to sort our data and make it right side up, okay? So here's how you do that. Go to the very top of your table, top left, any top row should do, and then up here in the sort and filter box, we can go down to filter and click that, and suddenly we have some buttons on each of our columns here. And if I want to sort not from big to small time, but from small to big time, I can click this box to say sort smallest to largest. And so now I have a normal looking set of data where the time starts at 0 and now it's counting up. Okay, so I'd like to graph this now. That's the trick. And you can change the size of all of these columns if you want things bigger. If you double click between columns, it will shift it to be just big enough to fit all the things that are inside. So that's another little trick. So now we have a nice looking table that we would like to graph. Okay, so let's plot our data as a scatter plot. Okay, and Excel is going to notice the kind of data that we have. If we select it all, it'll pick the best graph for us. It knows that we want a scatter plot out of this. Okay, so if you go to this, you select all of the data, then you go to Insert, you can look at a bunch of charts, okay, and select the one that's best for you, or like, oh, I want a bar chart, oh, I want a histogram, things like that. You can also click recommended charts because Excel is smart these days, and the very first recommended chart is in fact a scatter plot. It knows what we want. It knows that we have X values and Y values and we want to graph them, okay? And so if you click OK, this is apparently what we got out from the sensor. It should be looking more curvy, but the sensor's not perfect, and so that's what we're getting back. But that is the answer. That is how you draw a scatter plot in Excel. And so now we have a pretty graph as well as a pretty table, and let's make this chart even better looking. Okay, let's do some things. Let's change the graph title, maybe add a legend, show the axes, all that cool stuff that we need to do. If it's not already selected, where you want to be is not in Home or Insert anymore, but in Chart Design. This only appears once you select this chart here. Okay, and now we can change it. So you can pick any of these cool looking chart styles if you'd like, but the default one is fine. One thing that should change is maybe the chart title. Maybe in your class you were required to call it position versus time, because that's how it's working on the axes. So you can just double click and then you're able to edit the title of that chart. Okay, so that's that. Let's do legends as well, because what does this blue line mean? Let's see. Okay, so you can add a chart element and you could show plenty of things. You could show a legend. Where do you want it? Right, top, left, bottom. Oh, okay, so that was the position. Interesting. Or maybe this was the empirical position, what we measured. So we'll change that in a second. But something we could also do is show the axes. Okay, so axis titles in add chart element. You have primary horizontal and primary vertical. We want both. We want to mark both of them. So let's add both of those axis titles. And then you can double click to be able to change them. Okay, so this is time at the bottom. And usually you want to also include your units, right? So time in seconds, and up here is going to be position in meters, okay? Because it starts at 20. So that's looking a whole lot better. Maybe we'd like to change the name of this to be something like empirical position, like what we measured it to be. And to do that, to change that, you actually have to right-click on the chart finally, okay? Then you bring up this context menu, and if I remember correctly, it's gonna be in select data, believe it or not, because we have this saved right here, okay? And I think if we click edit, we can change the name from just the default, which is the top bar here, to something nicer like, I don't know, empirical position. Because in just a second, we're going to calculate the theoretical position, what it should have been. Okay? And so we went to edit, we changed its name, hit OK, and if we hit OK again, it will keep that saved for us. So now we've renamed what this blue line means. Okay? And that makes a bit more sense to us maybe. So that is a very nice looking chart. If you'd like, you can make this bold and everything. Like, this is just normal text, so you can make it bold, italic, whatever you need to do. Maybe that's better. What else? So we have a nice looking chart and a nice looking table. The last thing, or the second to last thing that I'd like to show you is let's use these cool things called formulas to calculate what the position should have been, because in a perfect world, the graph should have looked something like this, right? It's decreasing like that. It should be a perfectly smooth graph, but we didn't get that from our sensor that's imperfect. So let's calculate the theoretical position, the perfect position, what it should have been, okay? And that is, the position is, well, it starts at 20 meters, and then it gets smaller by 1/2 times gravity times t squared over time, okay? So as t changes, the position decreases, right? It gets closer to the ground because it's being pulled down by gravity. So let's do, we can do theoretical position, and we can make it pretty just like the rest of these. You can make it the same font size. It looks like I was using 14 up here. And now this column's kind of shooting off into the D column. We don't like that. You can double click in between C and D to have it resize itself. But now what we'd like to do is calculate what the theoretical position should have been based on the current time. So at 0, if you fill it in for this equation, it's just 20, right? But that's going to be different every time. So let me show you how to make an equation based on the time column and have it change, okay? So if you want to make an equation in Excel, you first type the equal sign, okay? So, and then I can start typing things and then Excel will calculate that, the answer to that equation after I'm finished. So I type an equals sign and then something that Excel needs to calculate down to a value, and if I hit enter, it'll run that equation. You see how I typed equals 2 plus 2, but it made 4. That is the trick, and that's what we're going to exploit here to calculate our theoretical position. Oops. So here, I want this to be based on the time column. So I want an equation, right, that is 20 minus 1/2 gt squared. 20 minus, I can just use 0.5 for 1/2. What's g? 9.8. What's t squared? Well, it's whatever the time in this column is. This is the A2 column. I can click it or just type it, okay? So it's now taking the information from whatever is in that A2 column, or A2 cell, okay? And I wanted that squared, so I'll use multiplication one more time by A2, okay? The star character means multiplication in Excel, okay? And it knows about the order of operations, so you don't have to draw parentheses or anything, but maybe if you want to be extra precise, you can. And so that's the equation, and it's based off of another cell. Isn't that nice? So that's what it should be at the very top, and yes, it is correctly 20 there. And now here's where the magic happens, because you remembered how I could drag to have it automatically complete the rest of these? I can drag this to have it automatically complete the equation based on the other time down here. You see how when I dragged it, it's not talking about A2 anymore, it's talking about, oops, I was editing the original equation still. Now it's talking about A3. It knows to look at this column at the same level as this cell, okay? Isn't that beautiful? And so now, if I just drag all the way down here, it's going to fill it in completely. And it's going to base its answer on this time. This column's getting its information from A5 this time. Isn't that super nice? And so it's automatically calculating what it should be, and then at 2.1, because you can't go underground, we can just hard code that to be 0, okay? And so that is now the theoretical position versus the empirical position, let's say, okay? And now we'd like to add that to our graph. So to do that, it knows nothing about this column just yet, but we can tell it about it by right-clicking on our chart, going to select data, and then we can add a new, it's called a series as far as Excel is concerned, so we'll say add series, okay? And what's its name? Theoretical position. And its x values are, if you just click, you can start selecting from the graph. It's the same as the original, these time values. That's what we want on the x-axis. And then the y values, it's filled in with just the constant 1. We want to delete that. Sorry that this is so small. We want to fill that in instead with this entire column. So you see how it lines up. We select the y values that we want for the x values. Okay? And that, my friends, will graph exactly what we need here. Hit OK, and now we have two series on the same scatter plot. And what do you know? That's looking a lot better. So if we zoom in here, you can see how this is the precise curve that the ball should have followed, but this is the imprecise stuff that the sensor read. All right, so that's our neat-looking theoretical and empirical precision graph. Isn't that nice? So that's our scatter plot. You can copy this, you can save it, right-click, save as picture, or you also get an option to save it as a PDF. But here is our table. Here is the graph that we have made from this table using formulas and filters and cool stuff like that. I guess the last thing that I want to show you, because sometimes this will come up in a class, is the line of best fit. Really, that doesn't make sense here. You can also have a curve of best fit, I guess. But you can add that in chart design. So add chart element. It is trend line, okay? And so you can click whatever one you want. Usually you want a trend line, so linear, but there are other options. So let's try linear for now. And which one do you want it based on? Well, maybe we'll do our empirical readings from the sensor. We'll draw a line based on that. So there is the line. It's added itself to the bottom. You can change how that looks. You can click on the line itself and do cool stuff with it. But that is the trend line in a nutshell. You can right-click on the trend line itself, go to Format, and change what happens over here. You can change its type to something different. Oops. It was linear. We can make it curvy, and you see how it follows what it should have been. That's nice. The last thing that you usually want to do in a lab, if you're going to print this chart out or something, is you want to display the equation of this trend line, this line of best fit. So you can just check down here in the trend line options, display equation on chart, and you can move that wherever it needs to be. Okay, that maybe is in the way. Let's move it somewhere else. And so that's the trend line now. Okay, that's the equation. And then maybe you also want an r² value to see how good that line fit the information. You can also check to display that as well. And so now that appears in your chart. And that is our final cool looking scatter plot. Okay? So hopefully you found this useful. There's going to be plenty of other videos that I'm going to link on this page, so please watch those too if you'd like to learn even more about just spreadsheets in general or Excel. So thanks for watching.